Good morning to all viewers. Today we will see how to simulate an AC voltage controller with various loads. So to refer the topic, you can refer Power Electronics by Dr. P.S. Bimla. So here we are going to simulate the circuit with these specifications. So the source is a sine waveform that is 100 sine omega t. The frequency is 50 Hz. In the thyristors we are going to take a upper circuit, so it is having these components: Rs equal to 750 ohms and Cs equal to 0.5 microfarad. Next, coming to load, we want to see the load to be discontinuous load, so resistance R is 10 ohms. To have discontinuous, L is small, so L is 15 millihenry, E equal to 20, and T1 and T2 we are going to fire at an alpha equal to 60 degrees. That is, thyristor T1 is triggered at alpha equal to 60, thyristor T2 is triggered at alpha equal to pi plus 60 degrees. So if we talk in terms of time period, frequency is 50 Hz, means time period T equal to 20 milliseconds. So we can see here. So if you take it as T equal to 0 to 2 pi, its time period, in terms of time it will be 20 milliseconds. Half time means it will be 10 milliseconds. If we see the circuit of AC voltage controller, the circuit will be like this. During the positive half cycle, T1 will be triggered at alpha equal to 60 degrees. During the negative half cycle, T2 will be triggered during its corresponding alpha equal to 60 degrees. That is, so T1 is triggered at this point, T2 is triggered at this point. So what are these two values means? This is alpha equal to 60 degrees with respect to this point, so it is nothing but 3.33 seconds, 3.33 milliseconds. For T2, so here we are going to trigger T1, here we are going to trigger T2. What is the time here means? With respect to this point, it is 3.33 milliseconds. With respect to this point, 3.33 means total. With respect to this point, how much it will be means? It is 13.33 milliseconds. So these are the triggering times. So the triggering for T1 is 3.33 milliseconds. The triggering for T2 is 13.33 milliseconds. Okay. So this is the circuit. So whatever be the load, that we will change here, R load or RL load, that we will change. So this is the MATLAB circuit diagram. Where all these blocks are available, you can see this page. So in what toolbox all these elements are available that are written here, you can see them. So this is procedure as usual. We will connect to them, we will simulate them, we will observe the waveforms. If there is any maximum value or RMS value, we will note them down like this. So the waveforms are like this, something. So this is the sine waveform, that is source waveform, let us say, source voltage. We are triggering at alpha equal to 60. So up to that point it is 0 voltage, then it is triggered. Next here also T2 is triggered at pi plus alpha, so up to that it is 0, then it is triggered. So the waveform will continue like this. This is the voltage waveform. As it is R load, current waveform will follow the voltage waveform. Source current, this is the source current, this is the load current. As it is a series circuit, both will be same unless you keep a freewheeling diode. Up to freewheeling diode, load current and source current will be same. Next, coming to RL load, you can see even though voltage is negative, thyristor T1 is not turning off because of inductor effect. So it will be negative until unless the current is 0 in the inductor. After that it will return to its V equal to 0 state. Next it is triggered in negative side by T2. Again it continues, and here it won't be 0 because of inductor effect. Still it continue. Now it is 0. So like this the waveform will continue in RL load. This is the corresponding current waveform. So the current is not 0 at this point. So voltage will still goes on to be negative. Why means T1 is still on. Coming to RLE circuit. So this negative is because of L effect, and as soon as the inductor current is 0, it must return to its original state. That is, if it is off means in RLE load V0 will be equal to V, that is this. Now here T2 is triggered, so it goes to negative and it will continue, and here inductor current is not 0, so it goes to the upper part also, and as soon as it reaches this point, there the inductor current is 0 and it must return to its original state, that is E, V0 equal to E. Again here we trigger, and so the waveform will follow the source voltage. Slowly it comes up to this point, and here it still continues to flow downwards. Why means the inductor current is not 0 yet, and as soon as we reach this point the inductor current is 0, so it goes to its original state, that is V0 equal to E, and the waveform will continue. This is the corresponding load current and this is the source current. Now we will see simulating this in MATLAB. So in previous classes we have seen how to connect all these things and all. So I am directly taking the circuit diagram. So I will show you the parameters. So what is Vs? So Vs is 100 volts, frequency is 50 Hz. So here a voltage source is connected, and this voltage source waveform is sent through go-to block, and it is collected here in from, and here you can see it goes into the scope. So the first waveform is the source voltage. So here we are using mux in order to see 0. Why means we want a reference point to be seen there in order to see that RL effect and RLE effect. So for reference I am going to take a constant block which is having 0. Constant value is 0, so that there will be a line, 0 line reference. So we are using mux in Vs and V0. So we are using mux to see the waveforms of Vs and V0. So through go-to block it reaches here. So in go-to block, the inside value SV, that is tag SV, must match with this tag. Then only there will be a wireless transmission of that signal. So this is SV, SV. So it goes, it ends here, and wirelessly it goes to this from, and it can be seen through this code. Next, to measure the current ISS, so here also it is wirelessly transmitted up to this SI, SI are matching, and here you can see the source current. Next, here we have thyristors T1 and T2. You will see the thyristor values. So to make it near to idealness, this is 0.00 something 1, 0.008. So here we need to place that snupper values. So here you have seen the snupper values as Rs equal to 750 and Cs equal to 0.5 microfarad. So Rs equal to 750 and Cs equal to 0.5 micro. Same way T1 and T2 must have the same values. Next, coming to Z1, these are important. So Z1. So this is the pulse to be given to the thyristors. So usually the amplitude is 5 or 3.3. Practically if we do means from microcontrollers we will have the outputs as 5 or 3.33. 50 Hz cycle means 20 milliseconds. So that is the period. So pulse width So the turning on must be greater than the latching current. So approximately we are going to take it as some 20%. Next, this is alpha. Alpha is 60 degrees, that is 3.33 milliseconds. That is Z1. If you go to Z2, everything is same except that alpha. Since it's 5, 20 milliseconds, 20 alpha is 5 plus alpha. That is 10 milliseconds plus 3.33 milliseconds. So it is 13.33 milliseconds. So those are Z1 and Z2. So this is to measure the load current. If you go to load RL, R is 10, L is 15 milli. Next E. RLE means, so E we are going to take it as some 20 volts. So E is 20. So here we are going to measure the RMS values and mean values. So inside also RMS frequency is 50 Hz, initial RMS value any some value. So in mean block also 50 Hz. So you can set the runtime as 0.06, and if you run the circuit and you see the waveforms, so you can see the zero line. So this is RLE load. So you start at this point. Here I am triggering that T1. So this is R effect. So here you will have L effect, that is negative waveform. As current is not zero yet, you will have some reverse flow also. Not reverse flow, voltage reversing effect. Then E, as current is 0, T1 is off and V0 will be equal to E. And at this point T2 is triggered, so the voltage is negative. And here the current is not at 0, you can see here current is not at 0. So you will have still current flow in that inductor, so the voltage is still reversing. And here current I equal to 0, as I is equal to 0, T2 is off and you will have V0 equal to E. Like this the waveform will go. This is RLE load. Next we can do modifications. So if you want only R, you can place R, apply, OK, and you save it, you run it. Now you can see this is RE. This is RE because I am not changing the ES. If you change E to 0, apply, OK. Now it is only R load. Now you run it and you can observe the waveform. Okay, this is simply R. Next I want to change it to RL load. So RL. R is 10, L is 15 millihenry. Save and run, and you can observe the waveforms. So this is R, so you can see L. After L effect is over, it is 0, V not equal to 0. So RL. So these things you need to observe, and we can note down the corresponding RMS and mean values also. Thank you for watching.